Welcome to Softree's Friday webinar. Today we're going to be looking at coordinate systems, and in particular how to really see what you're doing and prevent nasty mistakes by using Google Earth. So my name is David Mills. I'll be presenting today, and we will be recording this particular webinar. So if you come in late or if you want to forward it, it'll be up on our YouTube site pretty quick. Now let's go to, come on, next slide. There we go. Okay. Coordinate systems and projections. There is a little bit of confusion amongst a lot of our customers about exactly what a projection is and how you use it. So we're going to talk about that, and then we're going to talk about changing coordinate projections, changing transformations, or doing coordinate transformations, and I'll show you with some examples from our software. So RoadEng contains both the terrain module and the location module. We'll be using both of these, mostly the terrain. Terrain is mostly where we do importing of data and exporting of data, and it's actually the place that defines the coordinate system for our location design. We'll look at both. So we're compatible with a lot of different file formats. Some of them contain coordinate information. Well, all of them contain coordinate information. Some of them contain projection information. The obvious one for that is shape, ArcView shape. They have a PROJ file which contains coordinate projection information. ASCII files in general do not have that information stored with them. LandXML may or may not. DWG in general does not. So sometimes you have to know what projection you're working in. Other times the file will tell you. So our software, like most engineering software, works in a Cartesian coordinate system, X, Y, Z coordinates, and the Earth, unfortunately, is not flat. So to get around the contradiction, we project the plane of the Earth into a Cartesian coordinate system. And there's a whole bunch of different ways to do that. UTM is fairly common. It looks like you've peeled the Earth like wedges of an orange and flattened each one of them down. There's another coordinate system that's very common in forestry called well, the BC Albers. But the Albers coordinate system can be used anywhere, and it tends to have equal areas. So in other words, if you project a block boundary or some other property boundary that has a certain area, it doesn't matter which part of the projection you're in, the area will be correct. Some projections preserve area, some don't. Okay, so there's a lot of different coordinate systems, and I'll help you find some of those on the internet, and then maybe in the future it'll be easier. Of course, the Earth, being a sphere, is divided into latitude-longitude coordinates. They are not Cartesian in that the longitude axes converge at the pole, and I'm sure most of you are familiar with it. When you get data in latitude, longitude, you cannot display it in our software, at least not sensibly, unless you convert to one of the Cartesian coordinate systems. So RoadEng is good with reading lots of different kinds of data. You've got to be careful about bringing in multiple sources if they have different coordinate systems. And then we can export to various formats. Again, if you want to export to a well-defined georeferenced system like a GIS system, you probably want to know what coordinate system you're working in. I want to just are we ready to go? Yeah. A little bit of housekeeping before we get started here. As I mentioned already, this will be recorded. You can look at it later. There is a questions area in your GoToWebinar panel, and you can type in there. If you're lucky, I'll notice your question and answer it. Certainly by the end, I'll get to everybody's question. but do feel free to type in there at any time if you want me to answer a question. You're muted, so that's the only way you can communicate with me. Okay, let's get going. So I'm just going to get out of the, there we go, get out of the PowerPoint. Okay, so here's a fairly typical little road network. It happens to be logging roads, but it could be anything at all. Let's start from scratch. I'm going to start up our terrain module and bring in some data from shapefiles. So I don't need these right now. Put that down. Here's our terrain module. And file open. So I think, yeah, I'm in the right folder. And what kind of file? Well, if I go to all sources, it'll show me everything that's in here. Here's a shapefile. ArcView came up with this, or what are they called? Esri. Yeah, it's an Esri format, but it's used all over the place for transferring data from GIS system to GIS system. And in general, these things have coordinates defined. But watch this. I'm going to open this one here, and it's ready to come into our software, and it's telling me that the projection is undefined. The first time I saw this, I scratched my head a little bit, went back to the folder of interest, and is this the one? Took a look at all the files. It turns out that for the existing roads shapefile, that one, the PROJ file was missing, or PRJ, there it is. Without that file, the shapefile doesn't have well-defined coordinates. It has X, Y, Z, but we don't know what format they're in. Okay, so I'm going to cancel out of here and try again. I'll say file open. This time I'm going to pick my proposed roads. And this is what you normally get when you try to open a shapefile in our software. You get a well-defined projection. File contains georeference information, and then you can read it in. Now, the default is to use the same coordinates. And if I do that, everything will work fine, except I am now in Universal Transverse Mercator, UTM, coordinates. There we are. And now I can bring in my other roads too, so let's just do that quickly. So here's the existing roads, and oh, I did file open instead of file insert. Sorry, there we go. File insert, existing roads. Notice that it remembered the coordinate system here. That's kind of nice sometimes, but it still says down here, file does not contain georeference information. So I could actually change this if it was different. But it happens to be correct because it's remembering from the previous insert. And because these files are in the same coordinate system, they, of course, line up with each other. And it's fairly obvious now that this is a full road coordinate system. Okay, so I'm going to just change the line type and color for the existing roads. They're already selected. Oh, I didn't want that. I wanted that one. There we go. So here's a road network in UTM coordinates. Is it really lined up? Is it georeferenced with the Earth? In other words, can I extract lat-long coordinates from this? Let's see. So I go to my status window options. I'm going to add the lat-long display. And it's showing, let's just pick a feature, any feature, it's showing coordinates. Those look reasonable to me. I think that's where Oregon is, but I'm not 100% sure. So why don't I export this data back to a known system and see if it comes out correctly. So save as. Google Earth. Give it a name. How about test? Am I in the right folder? Yeah, that's fair enough. Actually, I've got one already in this folder. I'll just use that again. So the export options for Google Earth allow you to choose selected or all. I can, in this case, there's not many. I'll just choose all features. And also to open in Google Earth when you're finished. So it's running Google Earth. It's giving me some spam. There we go. And zooming into the area of interest. Boom. Now, if I zoom in closely here, you can see that these roads are pretty close to being lined up. They're not perfect. This one down on the lower right looks just right in the center of the actual road. This one up here is clearly offset by a little bit. No way of knowing exactly what caused these errors, but they're pretty typical. I've seen a lot of data, and often there's a discrepancy like that. But at least I know that it's correct. The lat long is correct. The data is in the right place. Good. So now I'm going to bring in some LiDAR data to match up with this stuff. So file open and go find my LiDAR files. These data files are very large, so I'm just going to bring in one of them. I'll just bring in the first one here. And, oops, I said open instead of insert a second time today. Let's try that again. So I want to bring in the first LiDAR file, and I just want the ground points, everything set up the way I want it. Let's look at the, well, I could thin it if I wanted to. No, I'm just going to read it in. Okay. But notice that in the projection tab here, it says that the file doesn't contain georeference information. In other words, we don't know the coordinates of the LiDAR file. Not yet, anyway. Well, let's hope we got it right and just read it in. So it's bringing in, what, 15 million? Is that right? Holy smoke. That's a lot of points. I'm going to cancel. We don't need to read the whole file. Right away, I can see that there's no new points here. Let's zoom extents. Oops. We've got a tiny dot at the top of the screen, and we've got the current point way down at the bottom of the screen. Let's see what's down there. This is a classic coordinate mistake. What we've got now is we've got the LiDAR data down here at a completely wrong location compared with my road data. What happened? Well, let's go back to some data that I have. Fortunately, the people who gave me this LiDAR data also gave me this really nice report explaining how the LiDAR was captured, and it's actually kind of fun reading. But here we are, projection Oregon-Lambert. Oh, okay, that's probably not UTM. So what the heck am I going to do? Well, there's two things I can do now. I could start from scratch, bringing in the roads again, or I could convert the LiDAR at import time. I'm gonna do the latter because I just want to do what we did for these customers, because they didn't want to work in UTM coordinates. And actually, if you had noticed, this is not just UTM; it's also feet. I mean meters. And in Oregon, they generally like to work in feet. So I'm gonna start again. So I say File, New. Let's open those shape files again. This time we know where it's coming from. It's coming from UTM, but I want it to be Oregon-Lambert over here. Now we provide a very small list of projections here that you can select easily with these drop-downs, but Oregon-Lambert isn't in there. So what I'm going to do is quickly go to Google, just type in Oregon-Lambert projection, and the first result is this one. And these guys are great, spatialreference.org. So they're telling me where it is on the Earth, all the stuff that is basic about projections. For example, WGS84 is called the datum. There's also a thing called the geoid, or is it? Yeah. Anyway, I'm not too sure exactly what all these things are. The shape of the Earth is defined by a standard, the datum, and a few other things that go with coordinate systems. But the really useful thing is this number here, EPSG number. That's all you need. Once you've got EPSG, you've got all the information you need for our software. So let's go back to our software. And I'm going to change the coordinate system for my design from the default, which is the UTM, to EPSG 2992. So I clicked on that from EPSG button. Well, let's do that again. I want to change this projection. It's not in my list, so I click on the plus button, and then I can type in here, which requires a lot of deep understanding of how these things work, or click on from EPSG, just type it in. Okay, and notice that it says up here Oregon Lambert in the first line. Great, so that's a piece of text. It's called WKT text that represents the projection. You can copy and paste in here if you understand the details. And WKT stands for well-known text, which is one of the craziest acronyms I've heard, right up there with TLA, three-letter acronym. Okay, so I've got my correct projection in the right-hand side, the projection of the file on the left-hand side, and now it's saying, do you want to apply a transformation from this to that? Yes. And now I have a screen layout, by the way. My default normal screen layout doesn't have lat long in it here, so I could go into the status options and set it up, but I'm just going to read in the screen layout called chords. And there in my status window, it's showing, well, nothing, because nothing's selected. Let's select something. Aha, coordinates. Those look good. Let's bring in the rest of the roads. Oops. So I'm going to bring in the existing roads. Use the same from coordinate system, the same to coordinate system, and convert. That worked because they're in the right spot. Again, I'm just going to change the line types so that they're distinct from the proposed roads. And finally, yes, I've got lat long coordinates. Are they correct? Well, let's just double check. So again, I'll do File, Save As, Google Earth, replace the existing one, open in Google Earth, and it's already open, so it just, yeah, there it is. The new ones are in the same spot as the old ones. So my two completely different projections have the same lat long coordinates underneath, which makes total sense. That's good, because it is the same place on the Earth. And now let's bring in the Lidar. So insert file. I'll just pick the first file again, and maybe this time I'll thin it out a bit. 1/10 of the points. There we go. There we go. Okay. Points are in the right spot. Perfect. What if I was bringing in the data and I got it in the wrong spot and I want to fix it after the fact? Okay. So let's make a purposeful mistake here. I'm going to insert that. Oops, went too far back. Let's bring in those existing roads again. And this time, let's mess up the import this could easily happen if the file does not contain georeference information. Bring it in. I don't see it. Where'd it go? Well, let's zoom extents. Oh, I got the same problem I had before. Now my incoming points are way up here, and my data is way down there. Let's just zoom in on that. So there's my points that I just brought in. They're already selected. That happens when you do file insert. I could select them by doing that as well. And then I want to put them where they're supposed to be. I've clearly made a mistake here. You can change the coordinate system after the fact. And this is just another selected feature operation, coordinate transformation. So I'm going to say, no, this is not where they come from. They're actually coming from, oh boy, which UTM was it? I think it was zone 10. And I remember it was meters. So let's just do that. If I got this wrong, it won't line up, right? And this is the to projection, which is the current design or the current document. Apply transformation. They disappear. Zoom extents. And it looks like there's only one set of data here, but actually, let's just move the ones that I have selected. You can see that they were placed right on top of the other ones, and I just moved them offside a little bit so you can see where they are. Okay, let's delete those. Right, so those are the basic operations. When you're inserting data, make sure you get the right coordinate system. It'll convert for you if you need to. If you have everything lined up, then you can display things on top of each other, right? I've got an image in here called GE image. It's a terrain where I inserted an image, and it's been saved, and it's all in the correct coordinate system, so it displays in the background correctly. And again, you're seeing little glitches here where they don't line up perfectly, but that's as good as I could get it. I had to georeference this by hand, and it wasn't perfect. By the way, if you're new to the terrain module, you may not know that backgrounds have this washout factor. So the default is 50%. If I change that to 0, then you see the full intensity of the background. The washout is just so you can see black lines easier on top of it. If you're working with a white line work, then you don't want to use the washout technique. Okay, let's take a look at a couple of other examples. What if you're working in the location module? Okay, so here's a location design. We've designed this new road. We got the profile and the plan all finished here, and we'd like to send this out to our GIS guys to say, here's where the new center line is. So, whoops, those curves don't look great on there, but anyway, it's all done. This is near Fraser River, I believe, or Thompson, I'm not sure, here in BC. So I finished the alignment, and I want to export this back to a georeference system. First of all, notice that the module setup, that's where we control projections for a document. The projection is set, UTM. Also notice that it's not modifiable. The reason it's not modifiable is, actually it says here, the coordinate system is defined by the terrain. So the terrain in the background that defines the original ground surface has a well-defined coordinate system, and we're not allowed to mess with that. Okay, so I got a well-defined coordinate system. I can extract lat long from this. So let's save as, oh, Google Earth isn't in here. Neither is shape. Both of those things are a nice way to get georeferenced information out and display it to somebody else. How can I do this? Well, it turns out the way you do that is you export to terrain. There we go. I'm just going to write over top of this file. So we take our location design, our our road alignment design, export it back to a Softree terrain, and you can export all kinds of things. You can export the cross sections, you can export a surface. I'm just going to export the center line. So I have nothing selected except center line. Got edit and terrain turned on, so it's going to jump right into the terrain module. There's my alignment. And now I can do file save as, and there's all those options, shape, KMZ. Let's do KMZ. Okay. So I'm exporting the selected features to Google Earth. Leave Oregon, fly up to BC, and there it is. So yeah, that's your reference, and now we could load that into a GIS system, or just give it to somebody to look on their Google Earth. I mean, that's all I need is the KMZ file. I don't know if you're aware of that, but once you have a KMZ file, like so, just to double click, we'll open it in Google Earth and show you the location. Well, let's do one more example, and then I think I'm finished. If there's any questions, let me know. I have a file in my yeah, let's just open it from here. So a lot of you who've been watching our webinars for the last few years have probably seen this example, Hart Road. So here's the terrain. It's got a lot of junk in it, and I happen to know that point there is this lat long. How do I know that? Well, actually, because I georeferenced and made sure everything was correct and threw that in there as a label just to kind of remind me. So I can export just the center line here, or everything, or selected features. Let's do the selected. Well, let's just do everything. I think it'll go fairly quickly. So save as. Let's call it test. Google Earth. Yep. Sure, right on top of it. And I'm going to export all features to show you what it looks like on Google Earth. And this is kind of a cool example, because what happened here is that the customer gave us, oh, now we're leaving BC, going back to Washington, northern Washington. There we are. So I'll turn this thing off in a sec, but this is the old road here. And you can see the alignment is going right down the center of the real new road. Let's turn that off right there. So the old road is gone, gone, gone. You can't see it at all. It's farmers' fields. And there's the new road exactly where they said they were going to put it. So that's kind of cool. You know, when I originally did this, the old road was in there and the new road wasn't. So I think we're just about done. Any questions? I don't see any in the questions window. Okay, I'm just going to quickly reopen the PowerPoint and remind you that we've got a couple of webinars coming up. So those are coming up in the next few weeks. Anybody interested in seeing these things, just register. And as per usual, you can go to our YouTube site and see the collection of all the historical ones. And the new one done today should be up there in a couple or 3 days, probably next week, early next week. Good. Thank you for your attention. Bye now.